This video is a very short and simple introduction to the second type of motion graph you have to know for physics, a velocity versus time graph, v versus t. That means that the v goes on the vertical axis because it comes before the word versus, and t for time goes on the horizontal axis. This kind of graph will make no sense at all unless you know exactly what velocity means. Velocity does not tell you where something is. It does not tell you where the car is. It tells you how it's moving, meaning it tells you both the speed of the car and the direction of the car in a single idea, speed and direction of motion. Here are some examples. A car is driving 50 miles per hour north, speed and direction. Second example could be a person. A person is running 15 meters per second, to the left. Direction is left, speed is 15 meters per second. Here's a picture of two cars, a red and a blue one, and it shows how we're going to distinguish, how we're going to tell the difference between right and left using math. Moving right will be a positive velocity, moving left will be a negative velocity. We're going to use that on the graph because up here are positive numbers for velocity and down here are negative numbers for velocity, and right in the middle is zero velocity, meaning no speed. That means standing still. So this velocity for car A is positive 30 miles per hour. Velocity for car B is negative 20 miles per hour because car B is moving left. Okay, now an important warning. You're used to position graphs, which tell you where something is. Velocity says nothing about where a car is. All it tells you is how fast the car is going in which direction, but it doesn't tell you where it is. Okay? Here's the standard way of making a velocity versus time graph. This axis will be time, and that means this is the zero mark here. This is 0. This could be like 1, 2, 3, 4 p.m. in the afternoon. This would be noon right there. This axis is velocity. Okay? Like any graph, this is 0 velocity, so that means 0 miles per hour. The speed is 0. These are the positive numbers, so this could be like positive 10, positive 20, and below the time axis are negative numbers, negative 10, negative 20, and to keep this easily understandable for an American who rides in cars, we'll say the velocity is in miles per hour. So the time is in hours, like what hour of the afternoon it is, 1 o'clock, 2 o'clock, 3, 4 p.m. And the velocity is in miles per hour as if you're looking at the speedometer on a car as you drive it or as your parents drive it, except it's a very special speedometer. If the car is going to the right, it tells you positive numbers, but if the car is going to the left, it tells you negative numbers. Okay, something very important. Negative 50 miles per hour is faster, meaning it's a bigger speed than, say, positive 40 miles per hour. Many students at some point in middle school, some middle school book or teacher will say negative numbers are smaller than positive numbers. That's absolutely false. It depends on the context. If you're talking about velocity, negative 50 is bigger than positive 40. Negative 50 just means left with a speed of 50. Positive 40 means right with a speed of 40. So which car is going faster? This one is. Okay. Negative numbers are sometimes smaller than positive numbers. For instance, temperature. Negative 50 degrees is colder and it means less energy than positive 40 degrees. So they can be smaller, but they're not always smaller. And we're studying motion in physics. In fact, in most things in physics, negative numbers are not smaller than positive numbers. It just means a different direction or something's different. For example, when you study electrons and protons, negative charge is not smaller than positive charge. It's just different. It's a different type of charge, but it's not smaller. Okay. So now we understand what velocity is, and we have these axes. This is v for velocity on the vertical axis. T for time here will make this hours, and this will be miles per hour. Okay, so how are we going to show? We need three things we need to be able to show. One, how do you show that a car is stationary? Well, that's when its velocity would be 0. And the 0 of a vertical axis is where the horizontal axis hits it, so that means 0. So this is stationary or still. The car is sitting still. Anything along here means sitting still. Okay? Then we need direction, right and left. Well, we said earlier, for right, we're going to say those are positive velocities and left are negative velocities. So if we start pointing some numbers on here, like this would be plus 10 miles per hour, plus 20 miles per hour, plus 30 miles per hour, everything up here, all of these would mean moving right. This would be moving right at 10 miles per hour, that would be moving right at 30 miles per hour. Okay? All right? And then down here, we'll make negative numbers red so they stand out. Just like any graph, that'd be negative 10, negative 20, negative 30. So how are we going to show left? The negative numbers. So anything down here, anytime part of the graph is down here, it means the car is moving left. All right, and finally, we have to be able to show slow and fast. In other words, a small speed and a big speed. Well, that is the absolute value of all of these numbers, meaning you ignore the sign and you just look at the number part. So the slowest you can possibly go is to be sitting still. So right here is stationary. Then if you're near here, that's slow. So this region here, these numbers here are slow. Likewise, these numbers here mean that the car is moving slowly just to the left. So like this would be to the right at 5 miles per hour. This might be to the left at 8 miles per hour. Those are slow. Okay, and then if you probably know where this is going next, and that's where is fast. Fast is when the numbers are bigger. So up here, that's fast. 30 miles per hour is faster than 10. Likewise down here, this is fast down here. The farther you are away from the middle, the faster the car is going. So these are fast numbers down here, fast numbers up here. You just look at the absolute value, 30 and 30. So that means 30 miles per hour to the left. That means faster. Okay? So slow is close to the time axis, close to velocity being 0. Fast is farther away, either up or down. Okay? This means fast to the right. This means fast to the left. And this means slow to the right, positive 10. And this means slow to the left, negative numbers. If you learn this and get it exactly right and don't have to look at your notes, don't have to think about it too much, but if you learn this, everything up here is right, everything down here is left, and the farther up you are, or the farther down you are means faster, you can do any velocity versus time graph if you get those things straight. Okay. Now let's do a few quick examples. We don't have a lot of time for this. We'll just do some quick examples. Okay, example A, we'll say a car moving to the right at a constant 20 miles per hour. Time, velocity, 10, 20, 30, 0, negative 10, negative 20, negative 30. And the velocity is in miles per hour. Time is in hours. Okay, so moving to the right at a constant 20 miles per hour. So it's moving to the right, so that means you're in the positive numbers. They tell you the speed is 20. And 1, 2, 3 p.m. The speed stays constant, so that means an hour later, the speed is still 20. An hour after that, the speed is still 20. Okay? Now, that creates a horizontal line because the speed is staying the same. This is completely different from a position graph. The ideas you had from a position graph, you cannot apply them to this graph. You have to like flip a switch in your brain and think, okay, the rules are different. Stationary, slow, fast, moving right, moving left. Completely different ideas from a position graph. On a position graph, a flat line would mean the car is stopped. On a velocity graph, a flat line means the speed is staying the same. So is this car moving? Yes, it's moving. Which way is it moving? Well, it's in the positive numbers, so it's moving to the right. How fast is it going? Well, it's at number 20, so it's moving at 20 miles per hour. But it's definitely moving. The patterns that you learned with the other graphs, the position graphs, you cannot use those patterns here. You have to think fresh. Flip the switch in your brain and think of what this means. It's like reading a special speedometer that can show right, moving right, and moving left. Okay, next example. Now let's draw a graph and put different examples on the same graph, but in different colors. So this is time in hours, and this is velocity in miles per hour, parked or 0, 10, 20, 30, 40, positive, negative 10, negative 20, negative 30, negative 40. Notice for negative numbers, you really need to write the negative in front of every one. Okay, so let's say car A, moving to the left, constant speed, and let's say 40 miles per hour. Okay, and we'll put little marks for the time. 1, 2, 3, 4, 5 p.m. So this car starts out at a speed of 40 miles per hour to the left. So it's in the negative numbers 40, and it says the speed stays constant. So an hour later, it's still 40. Hour after that, so that's it. That's car A. Okay. Car B, we'll say stay stationary, parked for 2 hours. Then moves right with increasing speed. Okay, so first starts out parked. Parked means 0 speed, means the speed is 0. Remember, this does not tell you where you are, it tells you how fast you're going. It tells how fast the car is going. Positive means the car is moving right, negative to the left, 0 means it's parked. So it says stays parked for 2 hours. So that's to there. The speed stays 0 for 2 hours. Then it starts to move right. So that means we have to use this part of the graph where the numbers are positive. It says the speed's increasing. So maybe an hour later it's 10. An hour later the speed is 20. An hour later the speed is 30. So staying at speed 0, and then the speed starts to gradually increase. It takes an hour to get up to 10 miles per hour. This is a very weak car, and then an hour to get to 20 miles per hour. So the speed is increasing, 10 miles per hour, 20 miles per hour. This is not position, it's speed, like you're reading a speedometer. Okay, next. Car C. We'll say at start it's moving to the right, constant speed of 30 miles per hour. Okay, then slows to a stop, and then stays parked. Okay, so first we have to have it moving to the right, so that means these numbers. The speed is 30 miles per hour, so there's 30 miles per hour, and it says the speed stays constant for a while. It doesn't say how many hours, so we get to pick. So I'm going to pick 2 hours. 30 mile per hour speed for 2 hours. Then it slows to a stop. That means the speed decreases. So an hour later it might be 20, and after that it might be 10, and then down to 0. That's decreasing speed. You have to think fresh on a velocity graph. It's not the same as the position graph. You have to think just speed. Over 20. Okay, so the speed is decreased down to 0. Then it stays parked for a while, so I go like this. At 0 speed, parked for a while. Okay, moving to the right at constant speed. Speed getting smaller. Still moving to the right because these are still positive numbers, but they're slower and slower and slower. 30, 20, 10, finally 0 miles per hour, and then it stays parked. Okay, let's do another example. This one I won't put any marks on it. You don't have to in order to do this. There's 0. You just think this is to the right, this is to the left, because these are positive, these are negative numbers. This is the slow area, near 0, and this is the fast area, far away from 0. Okay, car A. Starts out moving to the left, constant speed. Then 2, slows to stop. 3, stays parked for a while. And 4, moves to the right with increasing speed. Okay, so we do this one piece at a time. So first, at the beginning, at noon here, when t equals 0, it's moving to the left. So that means we're down here in the left numbers with a constant speed. It doesn't say slow or fast, so we get to pick, so we'll just say that. Moving to the left with a constant speed. That's part 1. Then it slows to a stop. A lot of people will want to either make it go like this or go this way, thinking down means slower. Fast, slow. Slow means you get closer to the middle where the car is parked, where the speed is 0. So this is slows to a stop when you're moving left. 2, from fast speed to medium to slow to stopped. Slows to a stop. Then it stays parked for a while. That's part 3. 0 speed. Okay? Then it starts moving to the right with increasing speed. Like that, to the right, increasing speed, slow, medium, getting faster, faster, faster. So that's part 4.